Hey, what is up, you guys? Incredible people on the Incredible channel, guys. Welcome to another episode on the Incredible Academics YouTube channel. So, last time on the previous episode, we had some technical issues. I don't know what happened, but the video just ended, abruptly. But I was almost done with everything. But I do apologize for that. The camera just took me off guard, and but anyway, let's look at today's topic. Today's topic is a little bit different because we're going to look at inverse functions for inverse functions for exponential, right? So exponential, what am I saying? So inverses for exponential functions. Inverses for exponential functions. This is what we're supposed to directly delve into, but the issue is that you see with exponential functions, the inverses, they've got a prerequisite. In other words, there's some prior knowledge that you guys have not covered yet, of which we need to go through, right? And that is logarithms. Okay, and I'm pretty sure you guys have seen on your calculators there's a log, whatever, log, two types of logs on your calculator. So that's what we're going to be looking into, two types of logs, right? So from now going forward, y'all will know exactly what those patterns mean, right? So you log of a, ln a, right? So log of a, it's the logarithm of a, and ln a, it's also the logarithm of a. It's just that the difference is that here the base is 10, here the base is e. So in general, a logarithm is like this: log of a base, right? A log of a base, and then a particular number here, it's equal to an exponent. Now, where is this coming from? Log of a base and then some number there equals to an exponent. Where is this coming from? So I'm gonna give you guys a quick example. So 2 to the exponent x. So let's say that now we want to find the inverse of this function. So obviously we need to swap things around. We're going to say, okay, x comes down here and y goes up there, right? And then now we're stuck. How do we then make our y to be the subject of the formula, right? That's where the logarithms come in, okay? Because this over here represents our number. So this is in the form of number is equals to base and then exponent. Okay, exponent. So number, that's your x, okay, and then base, that's your 2, looking at that, and then exponent, that's your what? That's your y. So that's the situation over there. So the rules of logarithms, right, the thing that we wrote over there. It says, okay, the logarithm of a base, and then number, all right, must be equal to the exponent. So meaning that if you've got a situation like that, this can be rewritten as what? What's the base here? So the logarithm of the base, log 2, all right, that's the base. The number is what? Wait, we're supposed to be looking at this. Yes. So the logarithm of the base is 2. The number is x, right? We're looking at this. The logarithm of the base, that's 2. The number, it's x. This must be equal to the exponent. What is the exponent here? The exponent is what? Y. And voila! The y is the subject of the formula now. Can you guys see that? So, yes. So the log of the base, right? The exponent, the number there is equal to the exponent. Okay? So, meaning that this is you can look for the log here on your calculator. You see, that's the log. So this is where you plug in your base, this is where you plug in your number, and that whole thing there represents the what? The exponent. So this is just, I mean, guys, listen, with the things that we're looking at, right, like the topic that we're discussing right now, this is all that you need to know, that the log of the base and the number is equal to the exponent. This is all that you need to know. Of course, we are going to cover some other rules of logarithms, but if you can remember this, I mean, you can, you know, get away without knowing the other, you know, rules. Yes. So let's look at a couple of examples. All right. Let's look at a couple of examples. So let's suppose that you're asked to find the inverse of y is equal to 3 to the exponent x. Okay, I mean, this is just an ordinary exponential function. All right, and obviously we're going to do the things, we're just going to swap these things around. We're going to say, okay, x is equal to 3 to the y, and then now our main objective is to bring down the y, to make the y the subject of the formula. But we've got a rule which says, remember, this is the number, this is the base, and this is the exponent. All right, and our formula says the exponent is equal to the logarithm. The exponent is equal to the logarithm of the base, which is 3, of the base, and then the number there. Right? So now it's okay, what is the exponent? The exponent is what? It's y. So y is equal to what? The logarithm of the base. What is the base here? Okay, the base is 3. And then what is the number? Number, it's x. Therefore, we've got our inverse now. This is the inverse. We'll do one more example. This is easy, you guys. Right, so another one. Let's say we are looking at y is equal to 1/3 to the exponent what? X. Slightly different one, where the base is a fraction. Okay, fine. So now we're going to say, okay, we can even rewrite this like must we rewrite it, because this is the same as 3 to the exponent -1 and then x, and then 3 to the exponent -x. Same function. So we can do the swapping. We know that x is going to be equal to 3 to the exponent negative y. Okay, right, and then remember what the rule says. Exponent is equals to the logarithm of the base and then the number. So we know this is the number, 3 is the base, negative y is the exponent. So negative y is basically equal to the logarithm of 3 to the exponent what? I mean the number is what? The number is x. Alright, and then we get rid of the negative minus the logarithm of 3 and then x. Okay, so this is our inverse. Okay, so that's how you use the rules of logarithms to find your what? To find the function of the inverse of the exponential function. All right, so now let's delve deeper into these rules of logarithms. So we've got another rule which says the log of any number, let's say x times y. It's just two ordinary numbers, okay? Yeah, x and y, these are real numbers. And then let's say the base is b. Okay, so the log of the product of x and y with base b, this, when we expand it, it's going to be the logarithm of x at base b plus the logarithm of y at base b. So these are basically identities, okay? So you can move from here to there or from there to there, right? Yes. So it depends on the situation. Sometimes we need to, when you're asked to simplify, you might find that you need to sort of like go back. And when you're asked to evaluate, you might have to, you know, expand. Depends. So also we've got this one, the logarithm of the quotient of so let's just say x divided by y with base b. Okay, so this is the same as what? The logarithm of x at base b minus the logarithm of y at base b. Okay, so if it's division, then you subtract. If it's multiplication, then you add. So this is the first one, this is the second one, and then there's also some basic rules that you guys need to know. For instance, the logarithm of x with base x. So in other words, if the number and the base are the same, our answer is simply 1. Okay, and also another very important one, the logarithm of any number x at base b with an exponent n can be expanded like this. We can take this exponent here and put it on the other side. We can drop the exponent, so it becomes n logarithm of x at base b. Okay, very important rule when it comes to simplifying logs and all that. Okay, we're not really gonna dwell much on these because let's face it, in caps there isn't that much, you know, of logarithms. Okay, yeah, but just to be safe, you do need to know the rules, but not in that much depth, you know. Yeah, so if you can touch the cream, you can get away. without knowing most of these things. So anyway, there we have it. And sometimes you're going to have the logarithm of I think I've touched enough of these, I think I've touched enough of these, but let me check if there isn't any other, tricky logs. Yeah, but I mean, I've touched most of the important ones. So I mean, if I were to proceed from here, you guys would get confused. But I mean, these are the main ones. There's more of these rules. Let me just show you guys quickly. You guys can see. You can search for this on Google, right? You'll find more of these rules, okay? And then just try to play around with them. Yeah, so you can see that the first 3 we've actually covered, and that's like the most important ones. Yeah, but for caps, really the one that's most applicable, it's this one. So even if you missed everything that I said, make sure that you understand this, because that one is going to come back to haunt you, I'm telling you. So what else do we need to talk about? Okay, so we now know how to find the inverse of an exponential function. So the next thing that we're going to do is we're actually going to start finding the inverse and plot at the same time. Okay, so we find the inverse and then we plot it on the same sort of axis with its main function. All right, so that's it for today, and I'm hoping to see you guys on the next episode, and I'm out of here. Peace out.